I'm a junior at Norwood High School, and my area of responsibility for our project was to identify the problem. And the problem was that a lot of snow builds up on the roof of our high school next to room 360. And what makes this a problem is that the snow lands on a weak section of the roof where the beams in the ceiling are very far apart. So it's all concentrated on a weak area, and by researching our problem, we can find a solution to all the snow buildup on the weak section of the roof.
Okay, great. Thank you, George.
My name is Brendan Black, and I'm a junior at Norwood High School. And my area of responsibility was to research the needed problem for our project. And the model school design is the design in Massachusetts where if towns decide to build their schools with this design, they will get 50% of what they paid reimbursed to them, which is obviously wanted and desired among towns. But the issue with that is the snow buildup, which is just discussed, is an issue. We need to figure that out, so we have to research what ways to eliminate this issue.
Okay, so Brandon, so now with the model school design, if everyone is using that same set of plans, and that same set of plans has a fundamental flaw like we have in this case, then all of those model schools are going to share the same problem, right?
Yeah, it's beneficial to every single school that decides to use this.
Great. Thank you, Brandon.
Hi, my name is Crowley. I'm a junior at Norwood High School, and my area of responsibility was to develop possible solutions for this project. And we went with a retractable awning, which will prevent snow buildup. And in that, we had to take account the direction of the wind, and it had to be visually pleasing to other people that are driving around town. And the school takes up a large portion of the town, and yeah.
Okay, so, and again, as you said, we're in a residential neighborhood. We have to find a way to keep the heavy buildup of snow up to 12-foot drifts. We have to keep that off of that, really the weakest area of the roof, because that area of the roof that we're getting the 12-foot drifts on is where the spans between the supporting joists are the largest, correct?
Yeah.
All right, thank you, Karan.
Hi, I'm Jake Vale, and I'm a junior at Norwood High School. And I will be talking about the best solution that we chose. So the best solution we chose was the retractable awning. And the number one reason why we chose the retractable awning, because it is aesthetically pleasing to the neighborhood around the high school. We didn't want the neighbors to be disturbed with not having the high school look good. And number two, the retractable awning is autonomous. It uses a servo to use a pulley to retract the channels. And it also uses passive energy to deploy the channels.
Okay, thank you, Jake.
I'm Nick Nauman, I'm a junior at Norwood High School. I'm here to talk about step 5 of the design process, which is to construct a prototype. And here we've constructed 3, and the first one that we made is this one. And we made this one to basically get the idea of a telescopic design. And what we learned from this one is that you're going to need an extreme amount of torque in order to lift all 3 of the supports. In here.
So if we can go back to this one for 1 second then. So Nick, they share a common axle, correct?
Yeah.
So all 3 gears are driven by a common axle?
Yep.
Okay, and if you could just walk us through how that one would actually deploy?
Well, it would basically go up by, it would just turn up from the extreme amount of torque. But another problem we have with this one is that these back here, we would need an extreme amount of room up on top of the roof, which isn't ideal for what we need. And it doesn't fully retract, which kind of doesn't really look good in front of the high school. And then once we completed this one, we went over here to this one, and we perfected just the one support, and this one worked great. And then once we completed this one, we went over here to we perfected the 3 support one, and here we even added the awning on this one. And the great thing about this one is that it has the huge motor in the back, which creates a bunch of torque, which is able to lift these supports no problem. And then we also, gravity, it helps bring these down, which means we don't even need the motor to bring these down, which is the great thing. Another great thing about this design.
So it deploys using a passive force, gravity, correct?
Yep.
And so you only need to add energy to retract it?
Uh-huh.
Okay, so that's really good. You're taking advantage of a passive force that already exists, right?
Yep.
All right, thank you, Nick. So Luke is going to demonstrate the operation of the awning here, the awning prototype. So he's going to retract it, he's going to pull it up by hand. And you can see the fabric cinching up there. Okay, and now we will let it deploy, Luke. Okay, good. And we can see that it's deploying mainly by, and of course, once it's built, it'll have more mass. So those, the legs will come out a little bit easier, correct? Okay, now what we're going to do is, Luke's going to put his safety glasses on. We're going to retract it, and this time we'll use the motor that's on the back side. So I just want to give a little view here before you do it, Luke, of the motor. So you can see we're using 2 pulleys, correct? All right, and let's go ahead. I'm going to make sure I get out here. And let's actually go ahead and let's do a first functional test here. So this is going to be in retraction mode. So it deploys passively. And we'll go ahead and test, Luke. Okay, good. And you can see it brought the legs back up. Okay, nicely done. Thank you, Luke.
My name is Clifton Clark. I'm a junior at Norwood High School.
I'm Jeff Muse. I'm also a junior at Norwood High School.
I'm Sean Donahue. I'm a junior at Norwood High School.
So part of this project, we had 3 prototypes, and the one that seemed best fit was this prototype. This one was fully autonomous, which is very important because you wouldn't want a person going out in the middle of a blizzard to retract an awning on a school that is 3 stories high. Also, for this prototype, we use elongated holes so that when we retract the awning, so the PVC pipe won't go backwards or just go back into we used smaller, like medium and large, different kind of sizes. Also, for the back, we used a torque gear ratio, so that would allow the drive gear to drive the driven, allowing less rotations.
Okay, and we said then in the final version too, Clifton, we said that what we want to do is we wanted to actually slow down the shaft. Yeah. So what ideas would you have then for slowing down the shaft, using the same motor?
Yeah, adding a bigger gear.
Okay, good. So you'd put a bigger gear up here.
Yep.
So your actual driven gear would be bigger. Yeah. You would keep your drive gear, the smaller one, the same size, but you would add a bigger driven gear, correct?
Correct.
Okay, good. Were there any other features that you wanted to point out here? I just want to get a shot of the 3 sections that you have of the retractor here. You can see that's a good view of it there.
Yeah, also when we retract the awning, it doesn't go all the way up, it just goes right before the PVC. So it doesn't go like back up on top of the building.
Okay. Very good. So it would tuck, wouldn't take up a lot of space. So it would be aesthetically pleasing as well, right?
Correct.
Okay, any other ideas you want to add in terms of communicating the solution?
That's pretty much it.
All right, excellent. Thank you, Clifton.
Dale Martin, junior, Norwood High.
Jake Wilson, junior at Norwood High.
I'm Gio Stiploda, also a junior at Norwood High.
Okay, so Jake, you're going to talk about step number 8, which is redesign, right? Go ahead.
Step number 8 is redesign.
And this is the reflective piece where we talk about all the things that, as we were building it, if we could do things differently, we would do these things differently, correct?
Yeah.
Okay, so that's a valid part of the, step number 8 is the reflective piece of the engineering design process. All right, if you wouldn't mind, Jake, if you could point out those parts to us, what would you do differently in the next version? What would you do differently?
We would make the telescopic part made out of 4 pieces instead of 3 so it can go up farther and tuck into a smaller space.
Okay, good. Anything else? I mean, you made some nice design change features as we went too, right? When we thought of different things, we took advantage of them. What did you do differently in terms of the cabling?
We doubled up the cables for redundancy. Instead of just using 1 rope, we used a rope and a copper wire.
Okay, good. Excellent. All right, so those are the 2 big things. And again, step number 8 in the engineering design process is the reflective step, right? Excellent job, guys. Thank you.